So we'll start. Good morning to all of you, those who have joined very late. Okay. So last class we have discussed, last session we have discussed the question number 38. Okay, electrostatics. This is chapter combination ആണ് electric charge and electric field, electrical potential and capacitance. Together place it as a questions over here. Electrostatics. Okay. So we'll continue from question number 39 onwards. What is given there? 4 identical capacitors as shown in the diagram. When the battery of 6 volt is connected between A and B, charge stored is found to be 1.5 microcoulomb, the value of C1. Okay. As I discussed in the theory class as well, if once you are getting some questions which is related to the capacitance diagram at the school, wherever you are attending, it's the same procedure. What you have to do means once you are getting some circuit diagram, you don't know what are all the things are series connection, what are the things are parallel connection. In such cases, what we can do, that's a point. Okay, so 4 identical capacitors we have here, right, and connected to a battery shown in the figure, and it is 6 volt battery. A 6 volt battery, question meaning 6 volt battery is connected here between the terminals. That's the meaning, 6 volt connected here. This connect this is a point between A and B. That are two terminals A and B. 6 volt connect C1, 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 4 capacitors under total charge. Total charge na this circuit would flow cheyana total charge ആണ് 1.5 microcoulomb. That's the meaning. Only this data is given. Question is what? Value of C1. C1 is the value contributed. Okay. So the total charge is equal to how much? 1.5 microcoulomb. So 1.5 into 10 power minus 6 coulomb. QT, total charge. Same way, total voltage. Total voltage given to the circuit is how much? 6 volt. Okay. So what is the total capacitance? Total capacitance is equal to, I can write it as effective capacitance of C1. Total capacitance of C1. So that I can write Q is equal to CV. I know the general equation. Charge is equal to C into V. Appa then QT neyudum, CT neyudum, VT neyudum. Okay, QT, CT, VT. So total charge equal to total capacitance into total voltage. Simple way. C1 in the value we need to find out. QT is given 1.5 into 10 power minus 6. Voltage is also given 6 volt. CT has to find out. CT means what? Effective capacitance of C1. So if in any entrance examination, if you are giving some circuit diagram like this one, so what you want to do means you give the naming. Naming in the sense you give the numbering. Numbering in the sense, listen here very carefully. You give this as 1. Okay, immediately. Then the other end you give it as number 2. This is a simple shortcut method to find out any equivalent capacitance. Any other junctions in which you have seen, give it as a number. For example, 1 or 2 or 2. So left side I can see one junction, this junction. The junctions you give it as a number. Right side also I have a junction, so I will give it as a number called 4. It's a common method, it's a common trick which you can apply. Now what you want to do? Now I want to find out effective capacitance between which terminals 1 and 2. In that cases, what I will do means 1 left side place 2 right side place. Okay. Then we will analyze the circuit. If once you are looking to the circuit, you can see if 1 and 3 see these dashed lines. 1 and 3 are short circuited. That is 1 and 3 ഒരു wire which connected on. So which means I can say 1 equal to 3. So I'll write 1 equal to 3 here. Same way, if you look over, he will be here. 2 is connected with a wire. In between 2 and 4, nothing is there. It's just a wire. It's just a wire. So wire is a short circuit connection, or it is indicate both are same. So 2 and 4 are same. Okay. Now I will connect the capacitance between these 2 points. Now if you see the first capacitance is where first capacitance is present between 1 the first line is called 1, this is 1 and 1 and 4. In between 1 and 4 we have which capacitance is available between 1 and 4, which capacitor is available? C1 capacitor is available, the green color. So between 1 and 4. So between 1 and 4, C1 capacitor is available, which means 1 is in the left side, 4 is in the right side. So we have one C1 capacitor. Let me take another color. So this C1 capacitor. So this C1 capacitor I have drawn. Then I'll come to the middle part. In middle, C1. C1 is connected where between, if you are looking over here, it is between 3 and 4. 3 and 4. So 3 left side on 4 right side on 2 capacitance between 3 and 4. So 1 capacitor, next 1 capacitor. So now this is C1 and this is C1. Next, again we look into this bottommost part. If you look into the bottommost part, between again we have 3 and 2. Between 3 and 2, we have one more capacitor. What is that? Again C1. So 3 is left side, 2 is right side, and here we have one more capacitor is available between 3 and 2. So 3 is left side, 2 is right side. So C1. Now our circuit is simple circuit. Now this is our connection. Now this will know easy to solve it. So how will solve it? The top capacitance is in what connection? Series connection. So if 2 capacitance are equal capacitance in series connections, what will be there? C1 C2 divided by C1 plus C2. About 2 equal capacitance series equal capacitance and 1 capacitor divided by total number C1. Based on the formula also you can solve. For example, C1 C2 divided by C1 plus C2 is the formula. But C1 divided by C1 plus C1. So C1 square by 2C1. So how much this will get? C1 by 2. It is, you will get it as C1 by 2. Next capacitor middle, next C1, then same way bottom also we have C1. So now we have 3 capacitors, A and B. This is in the equivalent circuit. We'll go to the next page. So now 3 capacitors are in what connection? Parallel connection. So I can write C total equal to 3 capacitors parallel. How will do? C1 plus C2 plus C3. So C1 by 2 plus C1 plus C1. So how much will come? C1 by 2 plus C1 plus C1 2C1. Then simplify 2 LCM. So what will get? C1 plus E2 multiply. So we'll get it as 4C1. So answer is how much will come? 5C1 by 2. 5C1 divided by 2 is the total capacitance. Now we have this formula on top over here. We will substitute the values to this formula. So what is our formula? What is our formula? Q is equal to, again we'll write QT is equal to and CT into VT. What is QT? Total charge is how much we have written? 1.5 into 10 power minus 6. That's a substitute. So 1.5 into 10 power minus 6. Total capacitance. Okay, so total capacitance is how much? So equal to, correct? Equal to that. So QT equal to CT into VT. So 10 power minus 6, which is equal to total capacitance 5C1 by 2 into voltage is how much? 6 volt. Then simplify, then I will get the answer. I know 6 and 2 will get cancelled, it become 3. So 1.5 into 10 power minus 6 equal to 15C1. 6 by 2, 3 and 3 into 5, 15. So C1 equal to 1.5 into 10 power minus 6. 1.5 into 10 power minus 6 whole divided by 15. In numerator, I can write it as 15 into 10 power minus 7 and divided by 15. So this will cancel. How much will get? 10 power minus 7 coulomb. Sorry, capacitance. So capacitance where my unit is not coulombs, capacitance is unit is farad. So this can be written as, so 10 power minus, and this can be written as 0.1 into 10 power minus 6 നേടാം. 0.1 into 10 power minus 6 equal to 10 power minus 7. So how much this will come? This I can return as 0.1 microfarad. I can return as 0.1 microfarad. Okay, we'll see any one of the options will be there. Okay, all options will be in microfarad, 2.5 microfarad, 15 microfarad, 1.5, and we have the option equal to 0.1 microfarad. Is this understood, all of you?
Yes, sir.
Okay. Then fine. Any doubt for anybody? Just interrupt me and you can ask. So let me see the answers over here, which I have typed over here. 0.1 microfarad. Question number 40. Important question. In the circuit shown here, C1 equal to 6 microfarad, C2 equal to 3 microfarad. EMF of battery 20 volt. Switch S1 is first closed. It is then opened. Afterwards, S2 is closed. What is the charge finally on C2? Non question. Okay. So listen here first. First, which switch is closed? First scenario. So let's put it as scenario number 1. First capacitance under the 3 microfarad capacitor. Listen very carefully. Important question. 6 microfarad capacitor. First is the S2. This open. Open means no connection. Second case S1 closed on. So idan S1. S1 closed on means it is connected using a wire. So S1 is closed. S2 open. S1 closed. That's first question. Switch S1 is closed. But S2 so S2 is obviously open stages and a voltage which is connected. And okay, this line is not there, right? This line is not there. Okay, and a voltage which is connected over here is 20 volt. This is a diagram. Okay, so in such cases, what we need to do means we need to find out the common potential. Switch based problem numericals normal case. We have to find out the common potential. Remember this one, common potential. How to find out the common potential? Common potential normally I call it as VC equal to simple formula C1 V1 plus C2 V2 whole divided by C1 plus C2. Formula definitely I have taken in the class. You might be remembering this one. Okay, C1 is first capacitor. Adilalla voltage. Adana V1. C2 is second capacitor. Adilalla voltage V2. Total capacitor. So C1, we'll look into C1. So this is our C1 and this is our C2. So C1 in the value 6 microfarad. So 6 into 10 power minus 6 nedam. Numerator 10 power minus 6 denominator 10 power minus 6. So both the numerator denominator 10 power minus 6 cancel. So I am not writing it explicitly. So 6 into V1. V1 is how much? V1 is the voltage across 6 microfarad. See, 6 microfarad capacitor, 20 microfarad capacitors. So both capacitors are in parallel connection. And 6 in parallel 20 voltage. 6 microfarad across, how much voltage will be available? 20 voltage will be available. So 6 into 20. Okay. Then next one is what? Next one is C2 V2. So plus C2 is how much? 3 microfarad. But the C2 capacitor is completely disconnected. Because what? Because S2 is open. As circuit iddatha. So it has no voltage because it is disconnected, wire cut down. So no voltage. Divided by C1 plus C2. C1 plus C2 means 6 plus 3, which is equal to 9. So how much will get? 120 divided by 9 is the common voltage. Okay, 120 by 9 is the common voltage. 120. Any doubt? Anybody asking? No. Okay. 120 divided by 9 is the common voltage. Now I am going to find out what is the question? Charge on C2. Now what will happen? Now what will happen in the sense like S1, you can see it is then open. First S1 close, then it is then open. Then S1 in open. Then afterwards what will happen? S2 closed. Now our circuit after this, after the first scenario, the second scenario is become the 3 microfarad capacitor and switch S2 closed. So, and 6 microfarad capacitor, and we have this S1 is opened. Here we have the battery also. Okay. Here we have the battery connection as well. So S1 if open on. S1 open on, what is the given situations will be there? This is 20 volts. So S1 open means e battery there is no rule because here wire will be cut. S1 open on. So S2 closed on. S2 closed on, these two are 2 microfarad capacitor. Now, common potential means potentials on this 6 microfarad. And first close is the 6 microfarad capacitor. So at time 3 microfarad open. Now 3 microfarad closed which means S2 closed but 6 microfarad connected to the voltage source 20 volt S1 open. Now, 20 volt has no rule here because what? Because S1 is open. This disconnected wire cut. Also, if circuit the voltage 120 divided by 9. 120 divided by 9 meaning what is our effective circuit? Our effective circuits look like this one. Look like this means listen to here. What is the meaning of 120 volt? I am saying like we have a 3 microfarad capacitor, we have a 6 microfarad capacitor. So 3 microfarad and we have a 6 microfarad. We have 2 capacitance will be here. Let me raise this one. And we have 3 microfarad and 6 microfarad. This capacitor total voltage on 120 divided by 9 volt. Here we are representing called common voltage. A common voltage derive because of the circuit. This circuit S1 closed on S2 open. So this common at the circuit 120 divided by 9 on total voltage. Okay. 120 divided by 9 is the common voltage. Means what is the meaning of this one? 120 divided by 9 voltage is available for 3 microfarad and 120 divided by 9 voltage is available for what? 6 microfarad capacitor. And the capacitor voltage 120 by 9 voltage. That's what we call it as the name called the common potential. Common for everybody. Okay. So this 120 by 9 voltages is common to all the capacitance is available in the circuit. That's why 120 by 9 is available over here. Now what we have to see? Now what our question is, we need to find out the voltage, the charge on the C2 capacitance. So I can write it as Q2 equal to C2 into V2. Q is equal to CV. Up charge on the Q2 C2 capacitor. What is C2? C2 is 3 microfarad. So 3 into 10 power minus 6. What is the voltage? 120 by 9 because it's a common voltage. Now once we solve this one, 3 and this 9 will cancel. 120 by 3 verum 14 verum 40 into 10 power minus 6 verum. This can be written as 40 microcoulomb. I can written as 40 microcoulomb. So 40 microcoulomb is the right answer for the question. 40 micro option number 3 is the right answer. Okay, so this question importance is what is the summary of the question? This question is the main pulse. Two capacitor, one battery, two switch. First, one switch close. That is S2 and S1. Definitely S2 first close. S1 the first close panna. Why? Because battery in some charge has to flow. S1 is connected with the battery. S1 is charge flow. S1 first close. The question will never ask you S2 is first closed and S1 is first open. Questions will never ask like this. Question will always ask like S1 is closed and S2 is open. Why? Because S1 closes a battery connection can establish. Only if connection can establish, only charge can flow from 20 volt battery. 20 volt battery the charge flow. Charge is flowing to where? Charge is flowing to 6 microfarad capacitors. But C2 capacitor disconnected. So we are going to find out a common potential. Common potential C1 V1 plus C2 V2 divided by C1 plus a common potential. A common potential, I heard the meaning in common to 6 microfarad and for 3 microfarad 6 microfarad this voltage common in the question the second part they have given S1 is now open, S2 is now closed. If S2 closed and S1 open circuit only two parameters. What are the things? 3 microfarad and 6 microfarad. Adukku rendukkum common aayittulla voltage aanu 120 divided by 9 voltage. Voltage means that voltage is for 3 microfarad and that voltage is for 6 microfarad capacitor. Now the question is asking, what is the charge on the C2 capacitor? This capacitor is our C2 capacitor. This capacitor is our C1 capacitor. C2 means 3 microfarad capacitor. So Q2 equal to C2 V2. Q2 means charge has to find out. C2 in the value given in the question, 3 microfarad, 3 into 10 power minus 6, voltage V2. V2 is a voltage, so voltage on the 3 microfarad capacitor. That is 120 by 9. And the same voltage is available for which capacitor also? 6 microfarad capacitor also. Adum 120 by 9. So we substituted in the formula Q2 equal to C2 V2. C2 and V2 value substituted. We got the charge 40 microcoulomb. Understood?
Yes, sir.
Okay. If you have any doubt for anybody, please ask. Okay. Okay. Question number 41. Two capacitors of capacitance 3 microfarad and 6 microfarad are charged to a potential of 12 volt each other. They are now connected to each other. They are now connected to each other with a positive plates of each joins to negative plates of each other. Potential difference across each will be. Potential difference across each will be. This question is a major hint. Positive plates of each join to the negative plates of each other. Which means what? See, normally capacitance in the connection. He played positive, negative, positive, negative. Positive with the negative connection. Okay. So, questions in the scenario. So, let me come from the beginning of the question. What is given in the question? 2 capacitance. What are the two capacitance? 3 and 6 are charged to a voltage of 12 volt. Charge 12 volt each other. They are now connected to each other. Now they are connected each other. How they have connected? With the positive plates of each joined to the negative plates of other. Positive plates of each means if positive plates of each means first in the positive plates which is connected to the negative, the positive plates of each joined to the negative plates of other. That first capacitance in the positive, another capacitance in the negative connections with it. That's the connection scenario. Positive with the negative. Okay. The potential difference across them. Normally, if here also, wherever also you are learning like this series and parallel combination of capacitance, a very common topic. What all the teacher will be taking, he will discuss this one. Then normally negative with the negative, positive with the positive item plate the connections were another. Positive with the negative plates connect. This question is not, I mean, this question is not series connection. This question is about parallel connection. So the expected connection is positive, positive, negative, negative. This is expected connection. But questions what they have given means, listen here, within the positive, within the negative. Two plates. This is connected. This negative positive item connective. This negative positive item, positive and negative item connective. So this is our question. This is our question. This is a normal scenario. Now listen very carefully. This normal scenario, how to find out? The question is asking the potential difference across each capacitor. So what is that meaning? That is called what we discussed before, which is called common potential. Common potential, what is the formula? C1 V1 plus C2 V2 divided by C1 plus C2. Potential on each capacitor means all the capacitors, the potentials are same, and that potential is called common potential. This is the formula. This is my connection. Now, in case connection change, positive, negative, positive. Common potentials in the formula C1 V1 minus C2 V2 divided by C1 plus C2. This confuse all these two cases. Normal case questions they are terminals petty. If they are not speaking anything about the terminal, then our general formula is C1 V1 plus C2 V2 divided by C1 plus C2. These questions positive terminal is joined to the negative plates of each other. Negative plates of the capacitance in a formula C1 V1 minus C2 V2 then, because the second connection reversed on our reverse negative reason. Now we'll substitute the values for this one. This is our question. We'll substitute. What is C1? 6 microfarad. 6 and 3 ആണ് രണ്ട് കപ്പാസിറ്റർ. So അതിന്റെ വോൾട്ടേജ് അപ്പോൾ നേരത്തെ சொன்ன மாதிரி தான் ന്യൂമറേറ്ററിലും മൈക്രോഫാരഡ് വരും, ഡിനോമിനേറ്ററിലും മൈക്രോഫാരഡ് വരും. Both will get cancel each other. So 6 into voltage 12 ആണ് minus 3 into voltage 12 ആണ് divided by 6 plus 3. രണ്ട് capacitance 9. 72 minus how much will come? 36 divided by 9. So 72 minus 36 means 36. 36 by 9 means 4. So 4 volt എന്ന് വരും ഇതിന്റെ answers. Okay. So answer equal to 4 volt. Option number 2 is the right answer. But C1 V1 plus C2 V2 divided by C1 plus V2 we can't apply because it's not common. Other common potentials are, but question is speaking one additional line with the positive plates is joined to the negative plates of others. അത് വരുമ്പോൾ ആ ഒരു കണക്ഷൻ റിവേഴ്സ് ആയി കണക്ഷൻ റിവേഴ്സ് ആകുമ്പോൾ ആ C2ക്ക് ഒരു എക്സ്ട്രാ നെഗറ്റീവ് വരും. അതുകൊണ്ടാണ് C1 V1 minus C2 V2 whole divided by C1 plus C2 എന്ന ഫോർമുല വരുന്നതിനുള്ള റീസൺ. Understood? Yes, no? Yes, no?